Here we're going to build a voltaic pile. I'm going to give you the ingredients of how we're going to, of all the parts needed to build this, and then we'll go on to build it. The parts that are needed are, I'm going to use 32 pence pieces, so basically ordinary UK 2 pence pieces here. So we're going to be using 30 of those. We're going to use a strip of copper PCB board, about 2-3 inches by say 10 inches or so. So I'm going to use this, and that's going to be for our cathode of our battery. For the other end, for the anode, I'm going to just use an ordinary steel 12-inch ruler. This comes in handy because you can, once you stack up the cells, you can just put a connector on the steel ruler and then easily move it on and off and adjust it to different voltages. The deco box, you've probably seen it a number of times now. So we're going to be using deco box so we can go through different values of resistance. We're going to use a voltmeter. I like using the analog meters quite a lot when I'm doing this because it's just, you just get more of a feel for what's going on. So I tend to use this mostly. An LED, because we're going to be able to light an LED with this battery, hopefully. With the voltmeter, we will have some crocodile clips so that we can connect things up. So we're also going to have a little bowl of water, some salt, and some absorbent kitchen towel, and that will allow us to build the cell. Just going to go through the steps we're going to do this. So step one, I'm going to build the cell in the lab, show you how it's done. I made 30 cells in total. All cells should ideally have the same voltage, so probably looking at, you want to build each cell to about 0.5 to 0.7 volts. Want to be somewhere in that region, but for this to work the best, you want those cells to be reasonably equal in voltage value. Step two, I'm going to build a test circuit, and then step three, we're going to measure both the voltage and the internal resistance of a single stack of 6 cells. And then step 4, we're going to do the same, measuring the voltage and the internal resistance, but for 5 stacks wired up in parallel. And then step 5, from the measurements, we'll calculate the currents for both the single stack and the 5 stack batteries, and we'll compare them. And then step 6, with the red LED, it's rated about 3 volts, we can finally check the visible difference between the parallel stacked voltaic pile and 2 AA batteries in series as a comparison. So we're going to use 2 normal modern batteries as a comparison to our voltaic pile. So I'm just going to go over some of the more detailed steps, just a sort of quick summary of some of these steps, what we're going to do. So step 2 here in that list, is construction of the circuit. So this is what we're going to be constructing. So here we've got, each of these will represent a bunch of cells. So we're going to have stacks of, I think it was 6 cells, I'm not quite sure, 5 or 6 cell stacks, but we've got 1, 2, 3, 4, 5 stacks of those cells. And what I've put here is a little resistance symbol to indicate that each one of these stacks will have an internal resistance. So when you draw this down in a circuit diagram, you can basically lay it out like this. So you can see here that these basically are, all these internal resistance will add up as a parallel resistance in the end. The bottom line here obviously will indicate our anode plate, which actually will be on the top in the actual experiment. I'm going to use that for the anode plate. And then this top line along the top will be for the cathode, which I'm going to be using that for that. So I've just read here what I've put. Each stack has an internal resistance, so all will add in parallel. Hence one stack will have a higher resistance than all 5 in parallel. So you can see that, if you've got one of these, it's going to have a much higher resistance. Because if you wire up a whole bunch, like in parallel and series resistor circuit, if you wire up a whole bunch of parallel, then the current's got many paths to get through. So obviously more current will be able to come through on a parallel paths. So less current will go through if you just had that on its own, then obviously less current can get through. It's going to have a higher resistance. Whereas you wire them up in parallel, obviously you can use your 1 over R, add 1 over R2, add 1 over R3 formula, and you'll find that wiring them up in parallel allows us to get more current through. So that's what we'll be showing there. The load resistor here will be the resistor decay box. The zinc anode plate will be the 12-inch steel rule, I've just said that. The copper cathode plate is the PCB board, and this voltage drop here across here will be read via the voltmeter. So the complete voltage drop, the open source voltage we'll be measuring, and the voltage drop when we've got a load on there as well. Within this arrangement, we could easily test out different combinations of cells between the cathode and anode plates here. Because of the way I've set it up, where I'll be stacking these cells on that large cathode plate, we can, if we wanted to, we could very easily with that arrangement to change things quickly and test out other combinations of cells. Right, in step 3, I'm just going to quickly go over this again. If you think of this whole thing as a black box, go back to here a minute. If you think of this whole thing as a black box, it's going to have an internal resistance. So remembering here our rules about voltage dividers. So we've got this internal resistance here, and we're going to be able to measure that, because what we'll do is we'll measure the open source voltage first, and then we'll know when we measure the open source voltage, and if we put any resistor across there and measure the voltage across a load, then obviously we know that this source voltage will be shared between the internal resistance and the load. So if we move the decay box until RL is showing half the voltage value, then we know that half the voltage is over there, half the voltage is over here. So in essence, whatever we've got then for RL will be equal to the internal resistance. So that way we find the internal resistance. It's basically a voltage divider. So I could just write down the voltage divider formula and work that out. But in words, I've just described it there like that. So in step 4, we're going to do the same thing, measure the open source voltage and then find the internal resistance using the 5 stacks. And then in step 5, with all the results, we can now calculate the currents for both the voltage setups and compare to the AA batteries. So once we've done everything, we're just going to compare our results with the AA batteries.